Hello, today I'm going to get you started on Distance Learning 1.1.1. So you need to go to the Project Lead the Way website and your classes and click on Principles of Engineering, of course. On the left-hand bar, we're going to slide all the way down until we get to Distance Learning support. Let's see. There we go. And then, so what we're going to do is we're going to click on the first one here, well, the second one technically. The first one you can do is this three-dimensional CAD program you guys can play on your computers, or your Chromebooks, I believe. We're skipping that. We're moving on to this one right here, the Simple Machines Investigation. We're doing this in lieu of actually building with the VEX parts. So there's some three-dimensional modeling of VEX materials that you get to do. All right, so anyway, we're going to analyze a few levers. I'm going to go through the first one with you, and then you'll work on the rest of them. So here we've got a first-class lever. We know it's a first-class lever because the fulcrum is in the middle, so this is the fulcrum. This is the resistance. It's a 1 kilogram mass, and 1 kilogram mass has a resistance force of 9.8 newtons. This is where we're applying our effort force. This is a little force meter. It's going to read out how much force we have to apply. So what we're going to do is skip down to the blank now. Now number 7, so on your paper label number 7. It says calculate the ideal mechanical advantage of the lever. In order to do that, we need to know the distances. It's the distance of the effort divided by the distance of the resistance. And how you're going to measure your distances is you're going to go to this on shape, three-dimensional representation of the lever, and we're going to do some measuring. So this is actually a pretty cool little bit of software. So if you click on the rotate, you can rotate this around. So if you were to build a lever, this is very similar to what it would look like on your VEX parts. So we're going to measure the distance of the effort and the distance of the resistance. So to measure, there's a little measuring tool here, and we want to go from the fulcrum, which is going to be this little axle right here, to the resistance, which is going to be the second little axle right here. So what we see is our minimum distance. This is the distance we want to record. This is our distance of resistance, or DR, is 5.58 inches. Now then we want to measure our distance of the effort. That's going to be the distance from the pivot point to where we're applying our effort, well, which we're applying somewhere over here. Now to unhighlight what you've already got selected, just double click, and that'll deselect it, and we can measure again. So we'll go from this axle again, and we'll go to this little square, that little thing right there, and that is it says 6.2. So that'll be our distance of effort, 6.2. So 5.5 and 6.2. So to find our ideal mechanical advantage in number 7, going back to number 7. That's going to be the D over the dir. So that's going to be 6.2 over 5.5. Did we say? So it's I think I did that right. The D was 6.2, and so that gives us a mechanical advantage of about 1.14. So on your papers, make the number 7, circle it so it's easy to find your numbers, and then do your IMA calculation for that. Number 8 is find the ideal effort force. Now remember, when we see ideal effort force, or when we see ideal lever, what that's saying is we can use phi d equals fer dir. So we're going to use our phi, our d and dir from before, and it doesn't tell you this, but the fer, the force of resistance, is 9.8 newtons, and you're going to use that for the whole activity. The fer is always going to be 9.8 newtons, so make a big mental note of that. So using phi d equals fer dir, so phi is what we're looking for. We're looking for the ideal effort force in number 8. And these are going to be similar to the calculations that you do the rest of the paper, so make sure you're following along. D, we measured the distance of the effort was 6.2. That's going to equal fer. Now the force of resistance I told you is 9.8 newtons, and the dir we measured was 5.5. So phi d equals fer dir. Solving for phi, we get the phi should equal 8.7. The next thing we're going to do is we're going to measure the actual effort force. So we're going to go, I don't know if you guys are going to be able to load these or not, but they've got some data from that little force sensor they showed pulling on it. So this is a little force sensor that you might use. And it looks like it says to use the maximum value. So the maximum value looks like it hits pretty close to 10. So we're going to use that as our phi in the next problem here. Which one are we working on? We're working on number 10. So the actual mechanical advantage is going to be fir over phi. The fir is going to be, again, 9.8. The phi we just measured was 10. So that's 9.8 divided by 10. We get 0.98. 0.98. And then lastly, to calculate the efficiency of the lever, well, the percent efficiency equals the AMA over the IMA times 100. So our AMA was 0.98. Our IMA was 1.1. So we'll take that, and we get an efficiency of 89%. Then they just switch to a different lever. So what I want you to do is you know, hopefully this was helpful to you. I want you to, every time you see these boxes, I want you to make a number and circle it, and then show your work for what you did in that box. So you should have 7, 8, 10, and 11 written down on your paper with those numbers circled and the work for that next set. Hopefully that is helpful. I'm not sure. I may need to give you some more hints as we go along here, but we'll just see how we do. And good luck. Just keep working on this.